All right. So we're looking at trig identities. I'm going to write down the ones I gave you already. All right. So you will have all in the end, right? On this one slide. So the first one that we did was tan theta is equal to sine theta over cos theta. I write in it tan squared because sometimes people don't see this one, right? So it's sine squared theta over cos squared theta. We also did sine squared theta plus cos squared theta is 1. We did cos squared theta is equal to 1 minus sine squared. We did sine squared theta is equal to 1 minus cos squared, right? We also did after, right? So that was the set I gave you last week, right? Now for some new ones, right? Sine A plus B, right? If you see sine A plus B like that, then the identity is sine A cos B plus sine B cos A. So you're switching around what you find in sine up, right? If I were to change it to a minus sign, I'll do it in blue. If I were to change it to A minus B, all you're going to do is change the sign in the middle to a minus. Okay, that's what the little dash underneath means, right? Then you also have cos. You also have cos A plus B, right? This identity is slightly different. Cos A, cos B. And if you have a plus, it's a minus. Sine A, sine B, right? If I change the sign to a minus sign, right? If I change the sign to a minus sign, then the sign on the right-hand side between the cos A, cos B, and the sine A, sine B is a plus sign. Okay? Right? Then we have tan. I'll put tan on this side. Tan A plus B. That formula is tan A plus tan B all over 1 minus tan A, tan B. If I were to change it to tan A minus B, then you just change in all these signs, right? So the little blue part is the change in the sign. Good. Right, so we have the signs. Now we have the last set of rules called the double angle rules. So if I ask you to find sine 2A, right? So I want to show you these in full, right? I want to show you how I got them. Right? So sine 2A is simply saying sine A plus A, right? If you go back to the first new rule I gave you for the day, as this one here, right? If I go back to that rule and you replace the B with the A, you will get sine A cos A plus sine A cos A. When you add them, sine A cos A plus sine A cos A, you'll get 2 sine A cos A. Okay, so this is the identity for sine 2A. Right? Then, of course, we have cos 2A. Right? And cos 2A, when you work it out, you'll get cos squared A minus sine squared A. Or, if you look at cos squared A, if I replace cos squared A with 1 minus sine squared A, you will get 1 minus 2 sine squared A. Next version, all these are different versions of cos 2A. The most popular, the second two, right? 1 minus sine squared. And if you replace sine squared, if you replace sine squared here with cos squared, you shall get 2 cos squared A minus 1, right? You have to know when to use them. You see this, the first one is hardly used, right? But the second and the third, this one is used when you want to get sine squared only. This one here is used when you want to get cos squared only. Right? So these are the two versions that are kind of popular. And last one, tan 2a. Right? Just replace b with a in the tan a plus b formula, and you'll get 2 tan a all over 1 minus tan squared a. And that's it. Those are all the identities you have to learn for trigs. The good thing, sometimes you will see in the new paper 2 format, you mightn't even get an identity question to do. But in the multiple choice, you got to be able to know these, right? Right, but still, we're preparing for everything. So let's go through this and let's make sure we can use them, right? So write them down, screenshot, print them, make sure you have them, right? These are all the rules that you need to learn. Copy down. Can you be running them down? I've copied down. I'm gonna try to prove a few, right? So we'll prove a few and we'll probably do a couple with the solvent. And this is the last thing that we have to do in trims. It took kind of long, but I have a piece of homework for you all to do, right? I want you all to look back at the differentiation video, at the integration video from earlier in the week. Right? I want you all to do that for next week, please. Right? The differentiation and the integration video, right? Because next week I'm going to do applications of differentiation. So I want you also to look at the differentiation video. So I'll run through a couple of examples on differentiation and then we do the applications. Anybody writing still? Anybody writing? No, everybody good, right? Everybody good? All right, nice. So let's try to prove some identities, right? So usual thing, I'm gonna give the identity to prove. You'll have to probably use the new rules and the old rules, right? Once you get it, just message QED, okay? So let's start with the easy one. All of these are proved, right? Let's start with the easy one, right? See if you could prove sine theta plus cos theta all squared is equivalent to 1 plus sine 2 theta. Try that. If you get it, message QED. Right, I have 8 people there, so I could get 8 QEDs, please. But you're warming up, yes. All right, good. Give you a chance. Right, we're just doing a few of these, right? Not much. All right, have one. One so far. Of course, you're working with the left-hand side, right? Take your time and expand it out. All right, 2. Right, you should have it by now once you're doing it. Right, so you multiply sine by sine, you get sine squared. Sine by cos, you'll get sine theta, cos theta. Cos by sine, you'll get back sine theta, cos theta. Cos by cos, you'll get cos squared, right? Separate it up, you'll get sine squared theta plus cos squared theta plus 2 sine theta, cos theta. Right, we know that sine squared, this here, sine squared plus cos squared is 1 plus, if you look at your identities, 2 sine theta cos theta is sine 2 theta. And that's it. Right, once you expand it, right, you're supposed to get it, right? Ishana, you didn't get that? Why you didn't get it, Ishana? All right, next one. Okay, you all didn't get an easy one, so I'm gonna get an easier one. That was supposed to be easy. Try this one, right? Hopefully you expand this one correctly, right? Let's see if we can get a few more QEDs this time. 2 cos theta plus 1 by 2 cos theta minus 1 is equivalent to 2 cos 2 theta plus 1. Right, Try this one. Let's see if we can get some more QEDs, please. Let's see if Sarah will get this one. And Petal. Cause if we riding downtown. Take your time, message the QEDs if you get it, right? Take your time with the expansion. Didn't call her yesterday. I tell Christine to call you and tell you just in case. Yeah, no, we are not having. Now we had no class today because of the rules and stuff about our. Okay. Alright. Anyway, I will talk to you during the week. Alright, and we will. But you're free on Sundays too. You're free on Sundays too. Alright. Alright. Okay. Yeah, I already did tell that. Yeah, I would have been there, but I was come about. Anyway, we will start from next week, and we will. I will have you Saturday and Sunday, right? Yeah. All right. I think I'll tell you what. Right, any QEDs? Any QEDs? Right, one so far, nice. Once I expand properly, it should be good to go. Let's see how we multiply this out. 2 cos theta by 2 cos theta, that's 4. That's 4 cos squared theta. right? 2 cos theta by minus 1 is minus 2 cos theta. All right. 1 by 2 cos theta is 2 cos theta. 1 by minus 1 is minus 1. So this is 4 cos squared theta. The cos will cancel. This will cancel with this, minus 1. Right. When you reach here, you might recognize, well, this is not really looking like the rule, right? So what you could do, as I showed you last week, is take the right-hand side a little bit, right? And just see how you can expand this out, right? This had cos only, right? This one had cos only in it. So we go into the cos, the two cos 2 theta identities, and we'll get 2, right? Let me write it a little bit lower down, right? So we have 2 cos 2 theta plus 1, which is the same as 2 by 2 cos squared theta, 2 by 2 cos squared theta minus 1, plus 1 on the end, right? So this is 4 cos squared theta minus 2 plus 1. When you work this out, you will get 4 cos squared theta minus 1, which is exactly what we have here, right? So as I told you, when you reach here, all you have to do is just write this out from the bottom up, right? So you will write 4 cos squared theta minus 2 plus 1, which is 2 by 2 cos squared theta minus 1 plus 1, which is 2 cos 2 theta plus 1. And that's it, right? That's the way you get your answer, right? Copy it down. Right, so sometimes you have to learn to use the right-hand side to help you with the left, right? Let's go again. All right, next one. Number 3. Sadly, this one's a little bit harder than the last one. Right, prove that 1 minus cos 2a all over 1 plus cos 2a is equivalent to tan squared a. Right, please remember that cos 2a has 3 options, right? And you have to choose the right one. I'm just giving you one little hint. Remember that tan squared is sine squared a over cos squared a. Right? So you want to get sine alone on top, cos alone underneath. So choose the right identities for cos 2a on top and then cos 2a underneath. All right? Take your time and choose the right one. Okay? Go ahead. Right? This one's supposed to be hard, right? right? We have 1 so far. Right, just make sure you choose the right identity on top, right? All right, nice, good. Good, I see a little improvement with this one, nice. So again, it's choosing the right identities, right? So for cos 2a, because I want sine squared on top, is 1 minus 2 sine squared a. Because I want cos squared only underneath, then I'm going to choose 2 cos squared a minus 1 underneath. Right? Multiply at the top, you'll get 1 minus 1 plus 2 sine squared a. Multiply with the underneath, you'll get 1 plus 2 cos squared a minus 1. The ones will cancel. This one will cancel here. This one will cancel here. So we'll be left with 2 sine squared a over 2 cos squared a. 2 will cancel, and you will get tan squared a. All right? Nice. Good. So I see that little improvement with that one there. I'm not going to do too much of these, right? I will change from these now. And we're going to take a look at a different type of question using the identities, right? Right? Using the identities. All right. So let's say I give you something like this. Suppose you're given this much easier, right? Suppose you're given sine A is equal to 12 over 13, right? And let's say, all right, yeah, let's just start with sine A is 12 and 13. And I want you to find tan A, right? How are we doing that? Well, we know that tan A is equal to sine A over cos A, right? We know what is sine A already, so we just had to figure out what cos A. What we do is, because these are trig ratios and they belong to the right angle triangle, then what we could do is we could take sine A and represent it on the right angle triangle. So if here is A, we know the opposite is 12 and the hypotenuse is 13, right? Remember, sine A is equal to opposite over hypotenuse. So the opposite is 12 and the hypotenuse is 13. Then we could find for x. So we could use Pythagoras' theorem here. 13 squared is equal to 12 squared plus x squared. When you solve for x, you'll get 5, right? We arrange it and solve for x, right? You will see that here's 5. So what does that mean? It means that since sine A is equal to opposite over hypotenuse, then cos A will be equal to adjacent over hypotenuse. And well, tan A, we don't have to go and divide it. We could get from a triangle. Tan A is equal to opposite over adjacent. And that's it. You're good to go. Right? So this should be much easier, right? Are you okay with this? You're okay with this? Message yes, please, or no. All right, copy it down. Let's do our next one. right? So in questions, I just say that's using the triangle rules, right? Of course, they could come and ask you, well, you know, what is sine 2a and those kind of things, right? So let's just pretend I asked you to find that, right? Actually, let's change it. Find, I'll put it in red, right? Find sine 2a. So now you have to come and write sine 2a is equal to 2 sine a cos a. So that's 2 sine a. We worked out sine a already. That's 12 on 13. And we worked out cos a, 5 on 13. And you're good to go. Just multiply it out and you're done. Right? Just multiply it out and you're done. All right. So let's try one now. Let's change it up a little bit. Right? Number 3, I think. Right? So let's say I gave you cos now. Suppose I told you cos A is equal to 4 over 5. I would like you to find a few things for me. Find for me sine A, find for me tan A, and find sine 2A. Right? Find sine 2A. Find all those things, please. I'd message your answers when you finish, right? So that's a finished message. Right, message your answers, please. All right, let's see what you have. So we could use the right angle triangle. Here's A, adjacent is 4, opposite is, hypotenuse is 5, right? When you work it out, you'll get here's 3, right? When you use Pythagoras theorem, right? So the first one, sine A. Sine A is equal to opposite over hypotenuse. Second thing, tan. Tan is equal to opposite over adjacent. And the last one, sine 2A is equal to 2 sine A cos A. So that's 2 by 3 on 5 by, push-ups. I write the wrong one. 3 on 5 by 4 on 5. So when you work it out, you'll get 12 on 25 or 6 on 25. Correct? 3 by 4. Oh, wait, no. That's cancel wrong. 12 by 2 is 24. 24 and 25. Sorry, wasn't supposed to cancel. Right, last one. This one's a past paper. Right, this time I'm giving you 2 sets. I'm giving you sine A. Right, let's say sine A is equal to 6 over 10. And I'm giving you cos B. Cos B is equal to, let's use something nice, right? Let's use 5 over 13. I would like you to find sine A plus B, right? Find that quick. That's the last one we're doing. I'm not giving you much. I see some of you all already sending answers. Or they're probably sleeping or by the beach or camping out somewhere and logging in. At least you're logging. That's the important thing. All right, try this one. Right, you just spend some time and go it over, please. Right, this is the last thing in trigs, right? Nothing new again. I just message your answer and we're done, right? I will stop after this. So let me see if I can get all to this, at least do one per month. After this, we're done. Right, take your time and do it and send the answer, please. Right, you just need 2 triangles, right? One with A and one with B. All right, nice. Let's see if I got it right. Right, so A, opposite is 6, adjacent is 10. Sorry, hypotenuse is 10, so adjacent is 8. B, adjacent is 5, hypotenuse is 13, so opposite is 12, right? Remember these Pythagorean numbers, you're supposed to know them, right? If not, you can just work it out, right? So we could see here that cos A is equal to 8 on 10, and we can see here that sine B is equal to 12 on 13. Therefore, sine A plus B, we know sine A plus B to be sine A cos B plus sine B cos C, right? Sine A is 6 over 10, cos B is 5 over 13, sine B is 12 over 13, cos A is 8 over 10. Right? So you have to multiply it out. So everything is over what? 130. Right? And this is 30 plus, yeah, that's 30 plus 12 by 8 is what? 96. Right? And then you can simplify it out. Right? 63 on 65. Nice. Right? For those who were very good. Nice. For those who fall asleep on math, right? Remember to look back over this video, please. Right? So I want you to look over these trigs. What I will do now is, since we did everything for the past 3 or 4 weeks on trigs, I'll do a trig summary video, right? So you can look back at that as well. Right? For next week, I want you to look at differentiation and integration video, right? I did that this week, right? Differentiation and integration. I want you to look back at those videos because next week I'm going to start the applications of differentiation. Okay? So I want you to do that for me, please. All right, so enjoy the rest of the day.